In this video, I am going to show you how to implement a center-tapped full wave rectifier in Multisim. This is one of the most important circuit in power electronics, and by the end of this video, you will understand both its working principle and how to simulate it step by step. So let's design the circuit. For that, we need an AC source and a center-tapped transformer and two diodes. And now we need load resistor. Now connect AC source to transformer and transformer to diodes and diode to load resistor. Now we need to ground the middle connection of the secondary winding, because when we ground it, this point becomes zero reference, and because of this, one half of the winding gives a positive voltage with respect to ground and the other half gives a negative voltage with respect to ground. This grounding is important for rectifier to work properly, because during the positive half cycle, the upper diode conducts and the current flow through the load resistor, and during the negative half cycle, the lower diode conduct and again current flow through the load in the same direction. Without grounding the center tap, there will be no proper returning path for the current, and the rectifier would not function correctly. Now connect the oscilloscope across the load resistor, and if you also want to observe the input signal, connect the oscilloscope across the input signal. And now change the color of output waveform. Now run the simulation. And if you look at the oscilloscope, you can clearly see the output waveform of our center tapped full wave rectifier. Notice that negative half cycle of the input AC has been inverted and combined with positive half cycle. As a result, load resistor always receive the current in the same direction, giving us a continuous pulsating DC waveform. And if you want to see how to convert this pulsating DC into smooth DC, then watch this video. And if you found this video informative, smash that subscribe button and like this video.